Hello everyone, today I'm going to show you the Smith chart using FILPAL EDS. The Smith chart can be considered as one of the most frequently used graphical tools to visualize vector properties of S parameters. So here I have launched the FILPAL EDS software. On the toolbar there are many icons, one of which is the plot. So I change this plot to Smith chart, and then on the left top hand side I can see there is the generate toolbox, so I can click expand to select all the components. So we have lump component, we have ideal transition line, and so on. So here I would use this lump element at the first start. So the port, to make it easier to understand later on and easy in terms of observation, I just make it 1 ohm, and then I take the resistor here and try to make it also 1 ohm, and then in every simulation we should have the ground, so we put the ground here as a termination. Then I click run. Before I click run, I have to change the frequency range. This is from 100 megahertz to 100 megahertz to see just the point, right? So you see that the point is on the center of the Smith chart. So now I want to see the observation when I change the value of this resistor. So I can make it as a variable x, and then I make it 1. So if I run again, it will be just here. Now I can try to tune this variable to see the behavior. So this is 0. That is the value of, I have to change the minimum, let's say 0.1 or 0.01, make it very small, and then here make it very high, and then I make the value to be 0.1. So now you can see that it is here. So this is the RL circle, the real circle. Then I can tune it. I can make it a step to be 0.1. So you see, if I increase the value of the resistance or the impedance, which is the most commonly used terms for the load, the impedance has the real part and imaginary part. For this one, the imaginary part is equal to 0. So if I move the impedance to higher value, so you can see that the point is moving to the other side. So as it increases further and further, it will reach the end. So one conclusion from here is that this part, which is the right hand side, is considered as the open circuit. And if I decrease the value, it will come to the other side. So this side is considered as the short circuit. So left side short circuit, open. The right side is open circuit. It's very easy to learn using this software tool. Now I want to show you, because the Smith chart is essentially the real and imaginary part plot of the impedance together. So let's drag one component, which is called the frequency invariant reactance. It can be capacitor or inductors. Just like capacitor, inductor has the frequency dependent. So here I connect, and then I make it as how many in ohm. So I can just say that is it should be J. Let's say J Y is another variable, J multiplied by Y, and then I can make my Y to be 1. So from the subject you learned before, or everyone knows that if you get the inductor, the impedance will be J omega L. So it will be positive if inductor. So now I get my Y equal to 1. So J1 will be positive. So you need to observe where it would go. It would be away from this red axis. Okay, let's take a look. Yes, it's going here. So you can see now that the imaginary part is 1, which is this here. And then when I change this value, let's say I make it I need to change the maximum and minimum. So I see it's going on here. So this represents this real the imaginary part of the impedance. So If I come down, like make it lower, then it will move to the other side. So I can make the value to be less than 1 or so. So just make, say, put it 0.1. Of course, I cannot make it 0.1 because the minimum is 0.5. So if I make it like this, 1, then I can see that it moved to here. Okay, so we can have another conclusion that this is the the inductive region. Now, if I change this to negative, then I run the simulation, it will come to the other side. So, 4 things that we have learned just with this illustration. Number 1, the left hand side here is the short circuit end, this right hand side is open circuit end, and the top will be the inductive region, and the bottom will be the capacitive region.